Hello everyone. So hi, this is Tiger again. We are talking about paper 2016, and this is going to be the first half of this paper. So this is pretty much an easy half paper, and let's take a look at how easy it could be. All right. As always, we'll start from question 1. So I would say that question 1 is a numbers and operations question. And it's just going to be on bitmas. So we just need to calculate the value of each of them. The first one is adding up to 15. The second one is adding up to 26. The third one is adding up, is operating to 7.5. And the option B is just going to be 7. Option D is just 6. Take away 20. That is minus 14. All right. So among these answers, I'm just going to compare which one of them is closest to 0. So if you know the idea of the absolute value, well, you will see that whatever has a smaller numerical value is going to be closer to 0, right? So the answer is going to be B because it has the smallest numerical value regardless the sign in front of it. And the next one. So which number is 21 less than 60,000? This is just a simple calculation question, so it belongs to the numbers and operations again. And I would say it is just a simple subtraction question. But of course, if you want to really make use of the skill to solve this problem, that's fine. Well, it's just not really necessary. We know that 60,000 take away 21 is 59,979. But then if you want to use the skill, we know that if it ends with 0 and it takes away 1, it's going to end with a 9, right? So that's the only one ending with a 9, which means the answer is going to be A. Okay? As simple as that. And then the third question, well, I would say that this is a word problem, but it is too easy and I won't be able to, properly classify it. So I would say it's just a word problem with calculations, or you might say that it belongs to other word problems, but that's not really valuable. That's not really valuable. So essentially, one lap is 400 meters. How many laps does each athlete run in a 5,000 meter race? So we just need to divide 5,000, which is the total distance, by 400, which is the lap distance. And you can see that that is going to be 12.5, which is equivalent to 12.5 if you want to put it that way, which is what the answer did. So it is going to be E. All right, 12.5. And the fourth question. The fourth question, I would say that it is a word problem related to age. So, well, you can say that it is a time problem, but then actually, well, it does not really make use of, like the properties of age in there. Like different people have the same age growth, such as that. So essentially, what this question is asking you to do is just 2014 take away 1,856. 59. And that's why we get the answer 155. So the answer is going to be C. So you can see that this paper is just requiring you to do a lot of calculations. So I was guessing that it is a different question sector for this year, which the questions are really frustrating sometimes because you will actually have to do calculations, right? And this one is again a numbers and operations question. And I would say that it's on the conversion of fractions to decimals. So you can see that we have 1 over 25 and 0.25. One of them is a fraction, one of them is a decimal. So you can do it either way, but then since all the answers given are decimals, we would probably just choose to convert 1 over 25 into a decimal, which means that we can first change it into an equivalent fraction with the denominator a power of 10. And then I will see that it's 0.04. So 0.04 adding 0.25 is going to be 0.29, which the answer is going to be A. All right. So that's what we have. And question number 6. Question number 6. So this is a sum difference multiple problem in word problems. And to be specific, it is a sum difference problem because we have a sum and we have a difference. And well, if you know the sum difference problems well, for the item that is being for the item that is small, we just need to add the difference and add the sum by the difference and then divide it by 2. That's how we can get the answer. But if you're not really familiar, you can use a bar chart to help you. So for the girls, that's going to be 30 more than the boys, right? And altogether, that makes 600, which means that if you pretentiously add 30 to the number of the boys, it will add 30 to the total as well. And that's going to be 2 times of the girls. So all you need to do is 630 divided by 2, and that is 315. Okay, so that's how we can get the answer for this question. And moving on to question 7. Well, this is even easier, like a unit conversion problem. So basically, I would say that it's about unit conversions. Probably it's a word problem, but it's simply just unit conversions. So 8 kilometers is approximately 5 miles, which if you turn 8 into 5, you are dividing it by 8 and multiplying it by 5, right? So what you can do to 1.2 kilometers is exactly the same. You just do 1.2 divided by 8 times 5, which you can calculate as 1.2 times 5 divided by 8, which is 6 divided by 8, and that's going to be 0.75. So the answer is A, 0.75. All right. Whew. And question 8. So another numbers and operations problem. And it will be on fractions this time. Essentially, if you observe the terms in the numerator, 2, 4, 6, 8, 10, so on, each of the terms is double that of the corresponding term in the denominator. Yeah? Each term is going to be double. Which means that altogether, the sum in the numerator is going to be double the denominator. So if I have 2 times the denominator over the denominator, it's just going to cancel out, and the answer is 2. So we have the answer A, which is 2. Of course, if you want to add them up, that's fine. There are not too many numbers in both of them. So feel free to add them up if you want to, but that's just not necessary. Absolutely not necessary. All right. And as for question 9, so this one is slightly more interesting. I would say it is filling in the operations game, or you can say that it's filling in numbers games. Well, but it's definitely going to be a miscellany question. All right, let's say it's going to be a filling in numbers. But essentially, it's just filling in some operations there. So how we can think about this problem is that we need to put some operations in between these digits to give a new number. So if I have 36, well, it's just 20 adding 16, and we get 36. So we know that it is a 2-digit number, and we are not allowed to use division, right? Which means that I'm just going to separate it into, smaller parts, such that I will be able to find the answer. And for 195, this time it is a big number, right? Which is close to 200. So we can start with something close to 200, like 201, and then I remove 6 to get 195. The same goes for 207, which is just the other way around. We add 6 to get 207. What about the last one, 320? Well, we can see that this time is a large number, and it has nothing to do with 200s, right? So what we can possibly do is either some addition, well, which doesn't work because it's too big, and multiplication to make it bigger, right? So we can do 20 times 16 and we get 320. So all 4 of them works, and the answer is E. That's how we can think about this problem and solve it. And then as for question 10, this is again a geometry question on the spatial imagination. So these kinds of problems comes up a lot. Sometimes it's easier, like this one. Sometimes it's harder, or like spatial recognition, you can say it's spatial recognition. So it says that squares folded exactly in half and half again. Well, we know a square has got 4 lines of symmetry, right? But then the 2 diagonals, if you fold along the diagonals, they are going to be the same shape, which is an isosceles right-angled triangle. Or if you fold it along the midway of it, you're going to get a rectangle, right? And then if you are to fold these 2 shapes again, you must fold them along their lines of symmetry, which the first one is going to be folded up into a smaller right-angled isosceles triangle. And then for a rectangle, it has 2 lines of symmetry. Both of them are either going to be folding into a rectangle or a square. And none of them is D, which means the answer is D, right? D cannot be the resulting shape. And as for question 11, this is a number theory question. And it will be on divisibility. So if you know the divisibility rules of these numbers like 2, 3, 4, 5 well, you will immediately see the answer. Because 12 is definitely a multiple of 2, so not this. Well, let's say this is correct. And 1, 2, 3 is a multiple of 3. If you add the digits up, 1 adding 2 adding 3, that's 6, right? Which is a multiple of 3. So this is correct too. And 1, 2, 3, 4 is a multiple of 4. We just need to see 34 divided by 4. It's not divisible. It has a remainder of 2, right? So it means that this is not a multiple of 4. And the answer is going to be C. Let's move on to the other ones to prove that I actually have got the right answer. So whatever ending with a 5 is going to be a multiple of 5. 1, 2, 3, 4, 5, 6. If it wants to be a multiple of 6, it needs to be a multiple of 2 and 3, right? First of all, we know that it is a multiple of 2 because it ends with an even digit. And then if you add all the digits up, you're going to get 21, which is a multiple of 3. So it is a multiple of 6 altogether. Hence, the answer is going to be C. 1, 2, 3, 4 is not a multiple of 4. All right? And question 12. I can't believe it. It's just going to be a unit conversion problem again. word problem. I will say that at least it has got something to do with time. So I will say that is a time problem. 525,600 minutes. You know that song? I'm not going to sing it. Otherwise, you won't be here for my next sessions again. Well, so that's what we have. And that's in minutes. Now, I want to convert it into a length of time. So first conversion I can do is converting minutes into hours by dividing 60. So you should have 8,760 hours. Right? So after the division, that's what you get. And then you're going to convert it into days by dividing 24. So you can see that that's going to be a little bit more complicated in your calculation. So if you're actually dividing it, you're going to see that it is 365. But then there can be a simpler way to do that, because you can see that week, year, decade, century, millennium, they are pretty much wide apart, right? So all you need to do is just to do an estimation. 8,760 is more or less around 9,000. 24 more or less around 25. So we know that 100 divided by 25 is 4. 9,000 is 90 times of 100. So that's going to be 90 times 4, which is 360. Approximately 360, which means that it is close enough to a year's time. Right? And then question 13, let's just put my head here. So question 13, I would say that it is again a miscellany question. And this one is not a number array problem. I would say that it is more similar to just a simple filling number game. So again, it is about filling numbers. We will need to put 1, 2, 3, 4, 5 such that the numbers in adjacent circles always differ by more than 1, which means that they can't be neighboring numbers, right? So which of these is the most restricting? Definitely it's going to be either 2, 3, or 4, those ones in the middle, right? So we know that 3 can't be next to 2 and 4, so it must be next to 1 and 5. And then also we can see that 2 cannot be next to 1 and 3. So it must be next to 4 and 5, which means that this is how we can fill in the circle. And the question is asking you what is the sum of the numbers in the two circles adjacent to the circle which contains number 5. So that's pretty easy. We don't need to do anything else. We just need to add 3 and 2 up. And that's going to give us the sum, which is 5. So the answer is going to be C for this question. All right? That's what we have. And as for question number 14, well, it is a geometry question. And finally, it requires a little bit of thinking there. I would say that it's about the angles. Well, you can say that it's the angles in triangles. So first of all, we can see that AB is equal to AC, which tells us that triangle ABC is isosceles, right? So angle ABC is going to be equal to angle ACD. Now we also know that BD is BC, which means that triangle BDC is also isosceles. Then the base angles are going to be the same, which means that, well, so let's mark these angles first. So ABC is that one, ACD is that one, and then it would be also equal to the angle BDC. All right, and now let's find out what is the value of these angles. So all you need to do is to take away the top angle 40 and divide it by 2. because the interior angle sum of a triangle is 180 degrees. Taking away 40, that's going to be the sum of the two remaining angles, which is 140. And because the remaining angles are the same, so you can say that each of them is going to be half of 140, that is 70 degrees. So now knowing that, actually, the only angle that matters is this one. Because as long as I know angle BDC, it is equal to angle DAB adding angle ABD. Because the exterior angle of triangle is equal to the two non-adjacent angles added together. I believe I have said that many times already, so you should have been familiar with it now already. And BDC is 70 degrees, as we have just calculated. DAB is 40 degrees, just there. And angle ABD is what we're trying to find. So 70 degrees is 40 degrees adding angle ABD, which means that angle ABD is equal to 70 take away 40, that's 30 degrees. So the answer is D for this one. All right. So finally, I got to use two colors in this question for my stamps. Thanks God. And finally, we have question number 15. A numbers and operations problem. I really don't like this year's paper, how easy it could be in the first few questions. And it's going to be on indices, right? So in the 5 mark zone, this year's paper is like super easy, really. Well, more or less similar to the year 2014, maybe even simpler. So let's say, how many of these 4 expressions are perfect squares? So again, this is the reason why I don't like this year's paper, because there are so many calculations to do. Well, I'm not saying that it's bad, but it's bad for a competition. A competition should not be testing you only with your calculation skills, but more importantly, it should be testing your mathematical thinking, right? So, 1 cubed adding 2 cubed is 9, that's 3 squared. If you add on 3 cubed, that's 9 adding 27, which is 36, and that's 6 squared. If you add on 4 cubed, that's 36 adding 64, which is 100, and that's 10 squared. Oh, squared. And finally, if you have 100, add on 5 cubed, you have 100 adding 125, which is 225, and that's 15 squared. So all of them, all the 4 are perfect squares. Okay? That's everything for 2016, the first half of this paper. How do you feel about it? Please let me know. All right, so I will see you next time on Thursday, I guess. Have a nice day, have a nice evening, and well, that's it for today. Thank you very much for coming. I'll see you next time. Bye-bye.